The gradient dy dx of a curve C at the point xy is given by this equation here. Show that y is increasing when this inequality holds. Solve this inequality then. The curve C passes through the point P, 2, 3. Verify that the tangent to the curve at P is parallel to the x-axis. The point Q, 3, minus 1, also lies on the curve. The normal to the curve at Q and the tangent to the curve at P intersect at R. Find the coordinates of R. So I think that's the question there then. So let's have a look at it. So first of all, show that y is increasing. So A part 1 then. So here dy dx, which is the gradient, y is increasing if the dy dx is positive, then the gradient is positive. Dy dx is greater than 0, then when this is greater than 0. So let's run a minus through it. So minus, write that second term first. Minus 20x plus 16 now. Running a minus through, timesing by minus 1 flips the inequality. 0 times minus 1 is still 0, of course. Divide by 2 all the way through then. We'll get 3x squared minus 10x plus 8. Divide 0 by 2 is still 0, of course. So there's our inequality. Solve this inequality as part 2 then. So let's have a look at that. So part 2. It's going to be 3x and x. And it looks like it's going to be 4 2's with 2 minuses to make a plus. So 3x squared minus 6 minus 4 is minus 10. Minus times minus is a plus. 4 2's are 8. That is less than 0. It's a positive number of x squareds. So it's a U-shaped curve. The roots are at 2. And the other root is at 4/3. And it's a U-shaped curve, isn't it? So it's going to come down in this little sketch here and go back up like so. So we can see that this quadratic is here. It's less than 0 when it's below that line. So we can see that x can go up to but not include 2. And it can go down to but not touch 4/3. So there's the inequality satisfied then. So the curve passes through P, 2, 3. Verify that the tangent at P is parallel to the x-axis. Okay, so the tangent at P, 2, 3. So P is the point 2, 3. Dy dx when x is 2 then. Let's see what the gradient of the tangent is then here. Here's dy dx. So we've got 20x. 20 times 2 minus 6 times 2 squared. Minus 16 is greater than 0. 40. We don't want greater than 0. We're working out the value, aren't we? Here. So we want to work out this value. 40 minus 6 4s are 24. Minus 16 equals 40 take 40 is 0, isn't it? So yes, so gradient is 0. And the line is parallel to the x-axis. Okay, good. So that was at x equals 2. So the equation of line, the equation of the tangent then, if it's a flat line and goes through P, equation is y is equal to 3, then that's the flat line it is, and that's the height it is as it goes along parallel to the x-axis. So that's the equation. So that was B, part 1. Part 2 then, point Q. Let's have a look at this then. Let's have a look at what point Q was. Q is 3 minus 1. And we're told, what are we told? Let's have a quick look. It's on the curve. The normal at Q and tangent at P meet at R. Find the coordinates of R. The normal at Q then. So at x equals 3, let's get the tangent gradient. And then we can get the normal gradient. Dy dx is equal to Here it is here with x is now 3, so it's 20 times 3, which would be 60. 3 squared is 9, 6 9s are 54. Minus the 16, there's the value with 3 put in. 6 minus 16 is minus 10. So there's the gradient of the tangent. So now we know the gradient of the normal. So at Q then, y minus the y value, double minus makes a plus, is equal to the gradient of the normal, which we can see as 1/10, because that's the tangential gradient, is times by x minus the x value at Q. So that's that. Now we know y equals 3 at P. That's the straight line. Y equals 3. So that's our other equation of the tangent at P, and this is the normal. So this is equation 1. This is equation 2. Therefore then, put the y equals 3 in. 3 plus 1 is 4, is equal to 1 over 10. X minus 3. So x minus 3 then, reading from right to left. Move the 10 up, 10 fours are 40. So x equals 43. Move the 3 across, 43. Okay, x equals 43 then. Okay, x equals 43. So, let's look back at the question and see what it was. Find the coordinates of R, wasn't it, the point of intersection? So x is 43, and they meet at R. So y is also 3, of course. So R, it has coordinates then 43, and the y value must be 3 because it's a flat line where they meet.